Good day everyone, I am Elaine J.D. Dallas and today I will be discussing Chapter 14 entitled JIT and Lean Operations. Before we proceed to the introduction part, let us know first the definition of JIT and Lean Operation. A lean operation is a flexible system of operation that uses considerably fewer resources than a traditional system. Moreover, lean systems tend to achieve greater productivity, lower cost, shorter cycle times, and higher quality than non-lean systems. Lean systems are sometimes referred to as just-in-time or JIT systems, which, owing to their highly coordinated activities and delivery of goods that occur just as they are needed. Just-in-time or JIT is a highly coordinated processing system in which goods move through the system and services are performed just as they are needed. In this chapter, we will describe the lean production approach, including the basic elements of these systems and what it takes to make them work effectively. This also points out the benefits of these systems and the potential obstacles that companies may encounter when they attempt to convert from a traditional system to a lean production system. Introduction. Lean operations began as lean manufacturing in the mid-1900s. It was developed by the Japanese automobile manufacturer Toyota. The development in Japan was influenced by the limited resources available at the time. Not surprisingly, the Japanese were very sensitive to waste and inefficiency. Widespread interest in lean manufacturing occurred after a book about automobile production entitled The Machine That Changed the World by James Womack, Daniel Jones, and Daniel Roos that was published in 1990. As described in the book, Toyota's focus was on the elimination of all waste from every aspect of the process. Waste was defined as anything that interfered with or did not add value to the process of producing automobiles. Let us proceed to the characteristics of lean systems. There are a number of characteristics that are commonly found in lean systems, and these are: 1. Waste reduction, a hallmark of lean systems. 2. Continuous improvement, another hallmark and never-ending efforts to improve. 3. Use of teams, cross-functional teams, especially for process improvement. 4. Work cells, along with cellular layouts, allow for better communication and use of people. 5. Visual controls, simple signals that enable efficient flow and quick assessment of operations. 6. High quality, in processes and in output. 7. Minimal inventory, excess inventory is viewed as a waste. 8. Output only, too much demand, throughout the entire system referred to a demand pool. 9. Quick changeovers, enables equipment flexibility and output variety without disruption. 10. Small lot sizes that enables variety for batch production. 11. Lean culture, which the entire organization embraces lean concepts and strives to achieve them. There are 5 principles embody the way lean systems function. 1. Identify customer values. 2. Focus on processes that create value. 3. Eliminate waste to create flow. 4. Produce only according to customer demand. And 5. Strive for perfection. There are numerous benefits of lean systems, as well as some risk. The key benefits include: reduce waste due to emphasis on waste reduction, lower costs due to reduced waste and lower inventories, increased quality motivated by customer focus and the need for high-quality processes, reduced cycle time due to elimination of non-value added operations, increased flexibility due to quick changeovers and small lot sizes, and increased productivity due to elimination of non-value added processes. There are also certain risks that often accompany lean operations, such as increased stress on workers due to increased responsibilities for equipment changeovers, problem solving, and process and quality improvement. Fewer resources, such as inventory, people, time, available if problems occur. And lastly, supply chain disruptions can halt operations due to minimal inventory or time buffers. As you can see in the PowerPoint presentation, that is an example of a tractor from John Deere, the well-known tractor supply company, bolstered profits during a recession by using a JIT approach to reduce inventory levels. However, when demand picked up as the economy strengthened, a shortage of parts led to stretch out delivery dates. Long lead times to replenish parts meant that in some cases harvesting equipment farmers wanted wouldn't be available until after harvest time. As a result, some farmers turned to Deere competitors to purchase needed equipment. The Toyota approach. Many of the methods that are common to lean operations were developed as part of the Japanese car maker Toyota's approach to manufacturing. Toyota's approach came to be known as a Toyota Production System, or TPS, and it has served as a model for many implementations of lean systems, particularly in manufacturing. Many of the terms Toyota use are now commonly used in conjunction with lean operations, especially the following. 1. MUDA, waste and inefficiency. Perhaps the driving philosophy, waste and inefficiency can be minimized by using the following tactics. Second, Kanban, a manual system used for controlling the movement of parts and materials that responds to signals of the need, which is the demand, for delivery of parts or materials. This applies both to delivery to the factory and delivery to each workstation. The result is the delivery of a steady stream of containers of parts throughout the workday. Each container holds a small supply of parts or materials. New containers are delivered to replace empty containers. Third, Hijunka. Variations in production volume lead to waste. The workload must be leveled. Volume and variety must be averaged to achieve a steady flow of work. Fourth, Kaizen. Continuous improvement of the system. There is always room for improvement, so this effort must be ongoing. Fifth, Jidoka. Quality at the source. A machine automatically stops when it detects a bad part. A worker then stops the line, also known as auto-nomination. Supporting goals. The ultimate goal of lean is a balanced system, that is, one that achieves a smooth, rapid flow of materials and or work through the system. The idea is to make the process time as short as possible by using resources in the best possible way. The degree to which the overall goal is achieved depends on how well certain supporting goals are achieved, and these goals are: 1. Eliminate disruptions. Disruptions have a negative influence on the system by upsetting the smooth flow of products through the system, and they should be eliminated. Disruptions are caused by a variety of factors, such as poor quality, equipment breakdowns, changes to the schedule, and late deliveries. Quality problems are particularly disruptive because in lean systems there is no extra inventory that can be used to replace defective items. All disruptions should be eliminated where possible. This will reduce the uncertainty that the system must deal with. Second, make the system flexible. A flexible system is one that is robust enough to handle a mix of products, often on a daily basis, and to handle changes in the level of output while still maintaining balance and throughput speed. This enables the system to deal with some uncertainty. Long sit-up times and long lead times negatively impact the flexibility of the system. Hence, reduction of setup and lead times is very important in a lean system. And lastly, eliminate waste, especially excess inventory. Waste represents unproductive resources. Eliminating waste can free up resources and enhance production. Inventory is an idle resource, taking up space and adding cost to the system. It should be minimized as much as possible. In the lean philosophy, there are 8 ways, and these are: 1. Excess inventory, which beyond minimal quantities, an idle resource takes up floor space and adds to cost. Second, overproduction, which involves excessive use of manufacturing resources. Third, waiting time, which requires space, adds no value. 4. Unnecessary transporting, which increases handling and increases work in process inventory. 5th, processing waste, which makes unnecessary production steps scrap. 6th, inefficient work methods, which reduce productivity, increase scrap, increase work in process inventory. 7th, product defects, which require rework, cost, and possible lost sales due to customer dissatisfaction. And lastly, underused people, which relates to mental and creative abilities as well as physical abilities. The existence of these ways is an indication that improvement is possible. Building blocks of lean production system. The design and operation of a lean system provide the foundation for accomplishing the aforementioned goals. The building blocks are 1. Product design, 2. Process design, 3. Personnel or organizational elements, and 4th, manufacturing planning and control. Speed and simplicity are two common threads that run through these building blocks. Product design. There are 4 elements of product design that are important for a lean production system. 1. Standard parts. The use of standard parts means that workers have fewer parts to deal with and training times and costs are reduced. Purchasing, handling, and checking quality are more routine and lend themselves to continual improvement. Another important benefit is the ability to use standard processing. Second, modular design. It is an extension of the standard parts. Modules are clusters of parts treated as a single unit. This greatly reduces the number of parts to deal with, simplifying assembly, purchasing, handling, training, and so on. Standardization has the added benefit of reducing the number of different parts contained on the bill of materials for various products, thereby simplifying the bill of materials. Third, highly capable production systems with quality built in. Lean requires highly capable production systems. Quality is a sine qua non without which not of lean. It is crucial to lean systems because poor quality can create major disruptions. Quality must be embedded in goods and processes. The systems are geared to a smooth flow of work. The occurrence of problems due to poor quality creates disruption of flow. Lastly, concurrent engineering. Engineering changes can be very disruptive to smooth operations. Concurrent engineering practices can substantially reduce these disruptions. Process design. There are 8 aspects of process design that are particularly important for lean production systems. 1. Small lot sizes. In the lean philosophy, the ideal lot size is 1 unit, a quantity that may not always be realistic owing to practical considerations requiring minimum lot sizes. Nevertheless, the goal is still to reduce the lot size as much as possible. Small lot sizes in both the production process and deliveries from suppliers yield a number of benefits that enable lean systems to operate effectively. Second, setup time reduction. Small lots and changing product mixes require frequent setups. Unless these are quick and relatively inexpensive, the time and cost to accomplish them can be prohibitive. Moreover, long setup times require holding more inventory than with short setup times. Hence, there is a strong emphasis on reducing setup times. In JIT, workers are often trained to do their own setups. Moreover, programs to reduce setup time and cost are used to achieve the desired results. A deliberate effort is required and workers are usually a valuable part of the process. Third, manufacturing cells. One characteristic of lean production systems, multiple manufacturing cells. The cells contain the machines and tools needed to process families of parts having similar processing requirements. In essence, the cells are highly specialized and efficient production centers. Among the important benefits of manufacturing cells are reduced changeover times, high utilization of equipment, and ease of cross-training operators. Fourth, quality improvement. The occurrence of quality defects during the process can disrupt the orderly flow of work. Consequently, problem solving is important when defects occur. Moreover, there is a never-ending quest for quality improvement, which often focuses on finding and eliminating the causes of problems so they do not continually crop up. Lean production systems sometimes minimize defects through the use of auto-nomination, which is an automatic detection of defects during production. Fifth, work flexibility. The overall goal of a lean system is to achieve the ability to process a mix of products or services in a smooth flow. One potential obstacle to this goal is bottlenecks that occur when portions of the system become overloaded. The existence of bottlenecks reflects inflexibilities in a system. Process design can increase production flexibility and reduce bottlenecks in a variety of ways. Sixth, a balanced system. Line balancing of production lines helps to achieve a rapid flow of work through the system. Time needed for work assigned to each workstation must be less than or equal to the cycling time. The cycle time is set equal to what is referred to as a takt time. Takt time is a German word for a musical meter. Takt time is the cycle time needed in a production system to match the pace of production to the demand rate. It is sometimes said to be the heartbeat of a lean production system. Takt time is often set for a work shift. Seventh, inventory storage. Lean systems are designed to minimize inventory storage. Recall that in the lean philosophy, inventory storage is a waste. Inventories are buffers that tend to cover up recurring problems that are never resolved, partly because they aren't obvious and partly because the presence of inventory makes them to seem less serious. Low inventories are the result of a process of successful problem solving, one that has occurred over time. Furthermore, because it is unlikely that all problems will be found and resolved, it is necessary to be able to deal quickly with problems when they do occur. Hence, there is a continuing need to identify and solve problems within a short time span to prevent new problems from disrupting the smooth flow of work through the system. And lastly, fail-safe methods. Fail-safing refers to building safeguards into a process to reduce or eliminate the potential for errors during a process. The term that was used initially was bakayoke, which meant foolproofing. However, due to its offensive connotation, the term was changed to pokayoke, which means mistake-proofing. Much of the credit for pokayoke thinking is attributed to the work of Shigeo Shingo, who extensively promoted the use of fail-safing in operations. That is all for my report. Thank you and keep safe.
Good day, everyone. So my topic for today is about personnel and or organizational elements. There are 5 elements of personnel and organization that are particularly important for lean systems. So first is the workers as assets, second, cross-trained workers, third, continuous improvement, fourth, accounting, and fifth, the leadership and or project management. So first, let us discuss the workers as assets. So workers as assets is a fundamental tenet of the lean philosophy is that workers are assets. Well-trained and motivated workers are the heart of a lean system. They are given more authority to make decisions than their counterparts in more systems, but they are also expected to do more. According to a study, businesses that consider people important assets, engage in training programs, and implement creative workplace practices are more profitable than those that do not. This is a groundbreaking study that demonstrates that seeing employees as assets to be developed rather than costs to be cut is the surest path to profits and productivity, said the Labor Secretary Robert Rich at a news conference. According to the research, Motorola Incorporated expects to earn $30 for every $1 invested in staff training, while Xerox Corporation discovered that by working with its employee union, able to cut production costs by 30% and cut the time it takes to develop new products in half. Cross-trained workers. Workers are cross-trained to perform several parts of a process and operate a variety of machines. This adds to system flexibility because workers are able to help one another when bottlenecks occur or when a coworker is absent. It also helps line balancing. Problems are those that obstruct or attempt to hinder the efficient flow of work through the system. When such issues arise, it is critical to address them swiftly. Some companies employ a light system to signal difficulties. This type of system is known as andon in Japan. A set of 3 lights is provided for each workstation. A green light shows that there are no issues. An amber light indicates that a worker is sleeping behind. And a red light indicates that there is a significant problem. The light system's objective is to keep those in the system informed and to allow workers and managers to know when and where problems arise right away. It is essential that all levels of management actively support and participate in problem-solving efforts, forming goals with the cooperation of employees, publicizing them, and meticulously documenting accomplishment are all above. Goals provide something real for employees to strive for, and acknowledgement can help retain employee interest and morale. One difficulty with continuous improvement is that once the simple improvements have been accomplished, it can be difficult to keep employees motivated to seek out new opportunities. Continuous improvement. Workers in a lean system have greater responsibility for quality than workers in traditional systems, and they are expected to be involved in problem solving and continuous improvement. Lean system workers receive extensive training in statistical process control, quality improvement, and problem solving. Accounting. Another feature of some lean systems is the method of allocating overhead. Traditional accounting methods sometimes distort overhead allocation because they allocate it on the basis of direct labor hours. But that approach does not always accurately reflect the consumption of overhead by different jobs. In some industries, other costs now represent a major portion of the total cost. Labor-intensive jobs may be assigned a disproportionate share of overhead. That in turn can cause managers to make poor decisions. Activity-based costing is an alternate approach of distributing overhead. This method is intended to be more accurate in reflecting the real amount of overhead consumed by a job or activity. Activity-based costing allocates traceable costs to various sorts of activities such as machine setups, inspection, machine hours, direct labor hours, and material movement after identifying traceable costs. The overhead for certain occupations is then calculated depending on the percentage of activities they use. Leadership and/or project management. Another feature of lean systems relates to leadership. Managers are expected to be leaders and facilitators, not order givers. Lean encourages two-way communication between workers and managers. Next topic is all about the manufacturing planning and control. 7 elements of manufacturing planning and control are particularly important for lean systems. and these are the level loading, pull systems, visual systems, limited work in process, close vendor relationships, reduced transaction processing, preventive maintenance, and housekeeping. This is the level loading. Lean systems place a strong emphasis on achieving stable, level daily mix schedules. Toward that end, the master production schedule is developed to provide level capacity loading that may entail a rate-based production schedule instead of the more familiar quantity-based schedule. Moreover, once established, production schedules are relatively fixed over a short time horizon, and this provides certainty to the system. Even so, some adjustments may be needed in day-to-day schedules to achieve level capacity requirements. Suppliers like level loading because it means smooth demand for them. A smooth production schedule necessitates a level production schedule. When a corporation manufactures a variety of products or product models, small batches are preferred to reduce work-in-process inventory and maintain flexibility. The extreme scenario would be to make one unit of one product, then one of another, then another, and so on. While this strategy would provide the best possible smoothness, it would be impractical due to the high setup expenses. Model sequencing begins with daily production requirements of each product or model. For instance, suppose a department produces 3 models, which is A, B, and C, with these daily requirements. 3 issues then need to be resolved. One is which sequence to use. Another is how many times the sequence should be repeated daily, and the third is how many units of each model to produce in each cycle. The choice of sequence can be influenced by a number of factors, the most important of which is usually the setup time or cost. Choosing an AC or CA sequence will result in approximately 20% fewer setups over time. If each model is to be produced in each cycle, the number of cycles will be determined by finding the lowest integer that can be evenly divided into each model's daily quantity. For models A, B, and C, shown in the preceding table, there should be 5 cycles. 5 can be evenly divided into each quantity. High setup costs may cause a manager to use fewer cycles. Trading off savings in setup costs and level production. If dividing by the smallest daily quantity does not yield an integer value for each model, a manager may opt for using the smallest production quantity to select a number of cycles, but then produce more of some items in some cycles to make up the difference. Sometimes a manager determines the number of units of each model in each cycle by dividing each model's daily production quantity by the number of cycles. Using 5 cycles per day would yield the following. In model A, which is the daily quantity is 10, and you divided 10 by 5, which will give you 2. So in model A, there will be 2 units per cycle, and you use the number 5 because the number 5 is the lowest integer value in the models. Pull systems. The terms push and pull are used to describe 2 different systems for moving work through a production process. Push system is when work is pushed to the next station as it is completed. Pull system is when a workstation pulls output from the preceding station as it is needed. Push and pull are phrases used to describe 2 alternative strategies for moving work through a manufacturing process. Work is pushed from one station to the next in traditional production environments, or in the case of the last operation, it is pushed onto the final inventory. In a pull system, on the other hand, work goes forward in response to demand from the next stage of the process. Each workstation creates just enough output to meet the following station's expected need. Work is still drawn by the demand generated by the following operation. Production begins only in response to utilization of the subsequent station. If a workstation waits until it receives a request from the next workstation before commencing its job, it will have to wait for the previous station to finish. Visual systems. In a pull system, workflow is dictated by next step demand. A system can communicate such demand in a variety of ways, including a shout or a wave, but by far the most commonly used device is the Kanban card. Kanban is a Japanese word meaning signal or visible record. When a worker needs materials or work from the preceding station, he or she uses a Kanban card. In effect, the Kanban card is the authorization to move or work on parts. In Kanban systems, no part or lot can be moved or worked on without one of these cards. And there are two main types of Kanbans: the production Kanban or the P Kanban and the conveyance Kanban or the C Kanban. Production Kanban signals the need to produce parts, while conveyance Kanban signals the need to deliver parts to the next work center. Using the formula N is equal to dt times the quantity of 1 plus x over C, where N is the total number of containers and D is the planned usage rate of using work center, T is the average waiting time for replenishment of parts plus average production time for a container of parts, and X, policy variable set by management that reflects possible inefficiency in the system, and C is the capacity of a standard container. It should be no more than 10% of daily usage of the part. This is to compute the ideal number of Kanban cards. And note that D and T must use the same units. Sample problem. Usage at work center is 300 parts per day and a standard container holds 25 parts. It takes an average of 0.12 day for a container to complete a circuit from the time a Kanban card is received until the container is returned empty. Compute the number of Kanban cards needed if X is equal to 0.20. So to find the number of Kanban cards, we must use the formula N is equal to dt times the quantity of 1 plus x over C. So D is equal to 300 parts per day and T is equal to 0.12 per day and C is equal to 25 parts per container. X is equal to 0.20. Substitute them and you will get N is equal to 300 times 12 times the quantity of 1 plus 0.20 over 25, which is equal to 1.728. Round to 2 containers. And note that rounding up will cause the system to be looser and rounding down will cause it to be tighter. And usually rounding up is used. Limited work in process. Movement of materials and WIP in a lean system is carefully coordinated so that they arrive at each step in a process just as they are needed. Controlling the amount of work in process in a production system can yield substantial benefits. One is lower carrying costs due to lower work in process inventory. Another is the increased flexibility that would be lost if there were large amounts of work in process in the system. In addition, low work in process aids scheduling and saves costs of rework and scraping if there are design changes. Work in process is determined by cycle duration and task arrival rate. Kanban and ConWIP are two general ways to regulate WIP. Kanban works best in a stable and predictable environment, allowing enterprises to quote clients for longer lead times. When there is a variety in a line, such as due to failures or quality issues, ConWIP is advantageous. Also, while Kanban focuses on specific part numbers, ConWIP can be easier in a mixed product setting than Kanban close vendor relationships. Lean systems typically have close relationships with vendors who are expected to provide frequent small deliveries of high-quality goods. Vendor relationships in lean systems are often close as vendors are expected to produce frequent little delivery of high-quality goods. Based on their own experiences, buyer can assist suppliers in converting to JIT production. In effect, the supplier becomes a part of a larger JIT system that integrates the buyers and suppliers' capabilities. Historically, there has not been a spirit of cooperation between buyer and seller. Buyers and vendors have had a relatively hostile relationship. Buyers take steps to decrease the number of suppliers on their list, focusing on maintaining close working relationships with a select few. Many customers try to identify local vendors to decrease the lead time for deliveries since they require regular minor deliveries. A supplier in a traditional system has no idea who the other suppliers are or what they're up to. There is a minimal foundation for making improvements because each supplier works to the buyer's standards. Lean manufacturing businesses, on the other hand, may utilize a tiered approach to suppliers. They use a small number of first-tier suppliers who work directly with the company or supply important sub-assemblies. The first-tier suppliers are in charge of dealing with the second-tier suppliers who supply components for the sub-assemblies, freeing the end customer of having to deal with a large number of suppliers. Some of the work done by second-tier vendors may be subcontracted to third-tier suppliers, and so on. Each layer only has to deal with people who are immediately above or below it. Supplier tiers. Lean production systems use relatively few suppliers, relieving the final buyer from dealing with large number of suppliers. Lean production systems rely on a small number of suppliers, allowing the final customer to avoid interacting with a big number of them. Reduce transaction processing. Many built-in interactions in traditional industrial systems do not create value. Jeffrey G. Myler and Thomas Volman defined a laundry list of transaction processing that constitutes a hidden factory in typical manufacturing, planning, and control systems in their famous paper, The Hidden Factory, and point out the enormous financial burden that results. The transaction can be classified as logistical, balancing, quality, or change transactions. The ordering, execution, and confirmation of commodities carried from one side to another are all examples of logistical transactions. Personnel for shipping and receiving, expediting orders, data entry, and data processing are all included in the cost. Forecasting, production, planning, production control, procurement, scheduling, and order processing are all examples of balancing transactions. Personnel costs for these and related tasks are included in the associated costs. Determining and communicating standards as well as monitoring, documenting, and follow-up operations are all part of quality transactions. Internal failures and external failures are all included in the costs. Engineering modifications and the resulting changes in specifications, bills of materials, scheduling, processing instructions, and so on are the most common types of change transactions. Engineering changes are one of the most expensive types of transactions. Preventive maintenance and housekeeping. Preventive maintenance is maintaining equipment in good operating condition and replacing parts that have a tendency to fail before they actually do fail, while housekeeping is maintaining a workplace that is clean and free of unnecessary materials. Preventive maintenance is used by lean organizations to reduce the likelihood of equipment breakdowns, but they must be ready for them so that they can swiftly restore equipment to working order. This could include keeping important replacement parts on hand and making other emergency preparations such as educating personnel to perform some repairs themselves. When failures do occur, they signal possible opportunities to take advantage of in a lean setting. Housekeeping is part of what is often referred to as the 5S, which are the 5 behaviors intended to make the workplace effective. And these are the sort, straighten, sweep, standardize, self-discipline. Sort is decide which items are needed to accomplish the work and keep only those items. Straighten is to organize the workplace so that the needed items can be accessed quickly and easily. Sweep is to keep the workplace clean and ready for work. Perform equipment maintenance regularly. Standardize is to use standard instructions and procedures for all work. And self-discipline is to make sure that employees understand the need for an uncluttered workplace. Value stream mapping is a visual tool to systematically examine the flow of materials and information involved in bringing a product or service to a consumer. The technique originated at Toyota, which it is referred to as material and information flow mapping. The map displays a full process which often begins with the receipt of items from suppliers and ends with the shipment of a product or the delivery of a service to a client. From the arrival of supplies through the transportation of the product, the map depicts all processes in the value stream. Time is one type of data that may be acquired throughout the mapping process. You can get a sense of value stream mapping from the following tips for developing an effective mapping of a value stream. One is to map the value stream in person. Second is to begin with a quick walk through of the system from beginning to the end to get a sense of the system. Third is to do a more thorough walkthrough following the actual pathway to collect current information and material or information flow. Lastly is to record elements of the system such as cycle times, scrap rates, amounts of inventory downtimes, number of operators, distances between processes, and transfer times. Value improvement for a product or a service embodies the 5 lean principles described earlier and repeated here. It begins by specifying value from the customer standpoint. You can see where the value stream mapping can help process improvement. One is to specify the value from the standpoint of the end customer. Second is to identify all the steps in the value stream and create a visual map of the value stream. Third is to eliminate steps that do not create value to create flow. Fourth, use next customer in the process demand to pull from each preceding process as needed to control the flow. And lastly is to repeat this process as long as waste exists in the system. Once a value stream map is completed, data analysis can uncover improvement opportunities by asking key questions such as what are the process bottlenecks, where do errors occur, which processes have to deal with the most variation, where does waste occur. All business organizations, whether they are primarily engaged in service or manufacturing, can benefit by applying lean principles to their office operations. This includes purchasing, accounting, order entry, and other office functions. Office waste might include excess inventory, overpricing, waiting times, unnecessary transportation, process waste, inefficient work methods, mistakes, and underused people. That would be all. Thank you.
Good day everyone, my name is Ivy Grace D. Alabata and I'm going to tackle about process improvement using 5W and 2H. What is 5W2H? So 5W2H is a method of asking questions about a process that includes what, why, where, who, how, and how much. So this approach is a very simple and effective technique for guiding people simply and clearly, as well as understanding certain situations, documenting them, identifying alternatives, and generating an action plan to solve them. So, I have here an example or an outline of the 5W2H approach. So let's go to Lean and Six Sigma. Lean focuses on waste reduction, whereas Six Sigma emphasizes variation reduction. Lean principles alone cannot achieve statistical process control, and Six Sigma alone cannot achieve improved process speed and flow. Lean and Six Sigma both provide customers with the best possible quality, cost, delivery, and a newer attribute and nimbleness. So some believe that Lean and Six Sigma are two alternate approaches for process improvement. However, another view is that the two approaches are complementary, and when it used together, this can lead a superior result. So that's why the two approaches in combination integrates Lean principles and Six Sigma statistical tools for variation reduction to achieve a system that has both a balanced flow and quality. Let's go to JIT deliveries and the supply chain. So JIT means just-in-time delivery. So just-in-time delivery is a strategy in supply chain management intended to sync orders to suppliers with production or delivery schedule. So direct suppliers must be able to support frequent just-in-time deliveries of small batches of parts, so that may lead to an increase in transportation costs if trucks carry partial loads. So moreover, the JIT delivery requirements may extend to other portions of the supply chain, in which case close coordination among supply chain partners is critical. So also, JIT delivery results in pressure for on-time deliveries to avoid production interruption due to stockouts. So I have here an example. So a company that sells home furniture items but doesn't manufacture item will order the furniture from the manufacturer when a customer makes a purchase. Let's go to Lean and ERP. So, Lean systems focus on pacing production and synchronizing delivery of incoming supply. So, SAP's Lean planning and operations. So, sorry for the typo. So SAP's Lean planning and operations module extends ERP to Lean operation by providing Lean planning and scheduling capability linked to customers' demand. So it enables labeling of schedule and synchronization of supply chain activities with paired company operations. So Japan and United States use this system, which is the Lean system, which leads their country to success and made other traditional manufacturer has attracted keen interest of lean system. So, lean systems is a production method aimed primarily at reducing times within the production system as well as response times from suppliers and to customers. So let's go to obstacle to conversion. So this describes some of the obstacles to lean success. So converting from a traditional system to a lean system may not be smooth. So examples. Cultures vary from organization to organization. So some cultures relate better to the lean philosophy than others. So if a culture doesn't relate, it can be an organization to change its culture within a short time. So, and manufacturers that operate with large amounts of inventory to handle varying customers' demand may have difficulty acclimating themselves to less inventory. Let's go to cooperative spirit. So lean systems require a cooperative spirit among workers, management, and vendors. So unless that is present, it is doubtful that a truly effective lean system can be achieved. The Japanese have been very successful in this regard, partly because respect and cooperation are ingrained in the Japanese culture. So in Western culture, workers, managers, and vendors have historically been strongly at odds with each other. So consequently, a major consideration in converting to a lean system is whether a spirit of mutual respect and cooperation can be achieved. So this requires an appreciation of the importance of cooperation and a tenacious effort by management to instill and maintain that spirit. So next is lean services. So the discussion of this has focused on manufacturing simply because that is where it was developed and where it has been used most often. So it is also important benefits can be achieved in services. So one is eliminate disruption. So for example, in number one, try to avoid having workers who are servicing customers also answer telephones. So next, number two is make the system flexible. So this can cause problems unless approached carefully. So often it is desirable to standardize work because that can yield high productivity. So on the other hand, being able to deal with a variety in task requirements can be a competitive advantage. So number three is reduce setup times and processing time. So these have frequently used tools and space parts readily available. So additionally, for services calls, trying to estimate what parts and supplies might be needed so they will be on hand and avoid carrying huge inventories. So next is eliminate waste. So this includes error and duplicate work. This keep the emphasis on quality and uniform service. Next is minimize work in process. This includes example of this includes order waiting to be processed, calls waiting to be answered, package waiting to be delivered, trucks waiting to be unloaded or loaded applications waiting to be processed. So, and lastly is simplify the process. So this works especially when customers are part of the system. Uh, Contains of self-service systems including retail operations, ATMs and vending machines, services, stations, and etc. So next is JIT services. JIT services was one of the major competitive advantage for companies that can achieve it. So because JIT service has the ability to provide service when it is needed, so that requires flexibility on the part of the provider, which generally means short setup time. So and also it requires deal communication on the part of the requester. Next is just-in-time 2 or JIT2. So, companies allow suppliers to manage restocking of inventory obtained from the supplier. So, JIT was popularized by the Bose Corporation. So, it is often referred to as vendor managed inventory or VMI. So similar to just in time, but with more of focus on the suppliers and customers relationship. Next is operation strategy. So operation strategy is the total pattern of decisions which shape the long-term capabilities of any type of operations and their contributions to the overall strategy. So, lean operations offers new perspective on operations that must be given serious consideration by managers in repetitive and batch systems who wish to be competitive. So, lean operations is an alternative to traditional operation that an increasing number of organizations are adopting. So the ultimate goal of a lean system is to achieve a balanced, smooth flow of operations. Supporting goals include eliminating disruptions of the systems, so making the system flexible and eliminating waste. So as an overall, teamwork and cooperations are important at all levels, as are problem solving abilities of workers and an attitude of continuous improvement. So that's all. Thank you and have a good day.